Water is added to 4.267 grams of uranium fluoride. The only products are 3.730 grams of a solid containing only uranium, oxygen, and fluorine, and 0.97 grams of a gas. The gas is 95% fluorine, and the remainder is hydrogen. Part A of this question asks us to determine the empirical formula of the gas. To find empirical formula, start with finding the number of grams of each element present in the compound. We are given that 95% of the gas is composed of fluorine and the rest is composed of hydrogen. That means that 5% of the compound is hydrogen. From here, we can convert the percent composition of each element into grams. We can assume there is a 100-gram sample of the compound, which means that there would be 95 grams of fluorine and 5 grams of hydrogen. Next, divide each element by its molar mass. We'll divide fluorine by 19.0 and hydrogen by 1.01. The next step is to divide the answers by the smallest value. In this case, 4.95 is smaller than 5, so we will divide both by 4.95. We will get the answers of 1 and approximately 1, or it's close enough to round up to. We then take these numbers and use them as the subscripts for our empirical formula. Since both the numbers are 1, we can leave them out as subscripts, and the final empirical formula is HF, or hydrogen fluoride. Part B of this question asks, what fraction of the fluorine of the original compound is in the solid, and what fraction is in the gas after the reaction? The question is basically asking how the amount of fluorine from the reactant side is distributed between the two products. We want to find the number of moles of fluorine on the reactant side, so we want to convert the reactant of 4.26 grams of uranium fluoride to moles of fluorine. To do this, we find how many moles of uranium fluoride are in 4.267 grams of uranium fluoride by dividing it by its molar mass of 352.03 grams per mole. Then we multiply by the molar ratio of 6 moles of fluorine per 1 mole of uranium fluoride. Once you multiply that out, you will get 0.0727 moles of fluorine as your answer. Next, we do the same process to find how many moles of fluorine are in 0.97 grams of hydrogen fluoride. We find that there are 0.0485 moles of fluorine in 0.970 grams of hydrogen fluoride. Remember that the question is asking for a fraction of the fluorine in the original compound to the amount of fluorine in hydrogen fluoride and to the amount of fluorine in the unknown solid product. We then divide 0.0485, the number of moles of fluorine given to us by 0.97 grams of hydrogen fluoride, by 0.0727 moles of fluorine, which is given to us by 4.267 grams of uranium fluoride. We then get a decimal answer of 0.6671, which can be converted into the percent 66.71%. This means that 66.71% of the fluorine in the original compound uranium fluoride is present in hydrogen fluoride. To find the percent fluorine in the unknown solid compound, subtract 66.71 from 100. You will get 33.29. Our final answer for part B is 66.71% fluorine in hydrogen fluoride and 33.29% fluorine in the unknown solid product. Part C of this problem asks us to find the formula of the solid product. To do this, we want to find the number of moles of each element present in the compound. We are given that the compound is composed of uranium, oxygen, and hydrogen. To start, I will calculate the moles of uranium in uranium fluoride. To find the moles of uranium, I use the same process as I used before in part B. I divided by the molar mass of uranium fluoride and then multiplied by the molar ratio of moles of uranium to 1 mole of uranium fluoride. We get the answer 0.0121 moles of uranium. Next, I try to find the moles of oxygen. To do this, I first need to find the moles of oxygen in water. However, we are not given the mass of water, so we have to calculate it on our own. The problem tells us that there are 4.26 grams of uranium fluoride, 3.73 grams of the unknown solid, and 0.97 grams of hydrogen fluoride. I know from the law of conservation of matter that the total number of grams on the reactant side should equal the total number of grams on the product side. So I know that 3.73 grams of the unknown solid plus 0.97 grams of hydrogen fluoride minus the 4.26 grams of uranium fluoride should equal the mass of water, which equals 0.433 grams of water. Now I can finally convert from grams of water into moles of oxygen. To do this, I do what I've done before by dividing by the molar mass and then multiplying by the molar ratio of 1 mole of oxygen to 1 mole of H2O. We get an answer of 0.0241 moles of oxygen. Next, we find the moles of fluorine. To find this, we subtract the moles of fluorine from uranium fluoride by the moles of fluorine from hydrogen fluoride. So there are 0.0242 moles of fluorine in the unknown solid product. Now that we know how many moles of each element are present in the compound, we can calculate the formula. To do this, we follow the same steps that we followed to find the empirical formula of hydrogen fluoride. However, since we already have moles of each element, we skip the first step of dividing by molar mass. We go on to the next step of dividing by the smallest value. In this case, it's 0.0121. Once we divide each number by 0.0121, we get 3 whole numbers, 1, 2, and 2. These numbers become the subscripts for our formula. So the formula of the unknown solid compound is UF2O2. The final part of this question asks us to write a balanced chemical equation for this reaction. So I use the ERP method to balance the equation. The final balanced equation is uranium fluoride plus 2H2O yields 4 hydrogen fluoride plus UF2O2.